Hello, my name is Don Schenecker. I am the Product Marketing Engineer for the SAS and Sata protocol analyzers from Agilent Technologies. Today I'm going to demonstrate the SAS and SATA protocol analysis solutions from Agilent Technologies. These products are manufactured by Serial Tech Technologies. Today what I'm connected to is a SATA disk drive for a laptop connected out here through the analyzer to a laptop connected in the back. I have the U3052, which is a 4-port analysis solution. We also have a 2-port version, and there's a separate product that goes for the 12 gigabit SAS analysis. Today we'll do a demonstration of the complete functionality and demonstrate how to do the analysis. For this demonstration, what I have connected to my PC is one bus expert. It's monitoring 4 links across the operation. I can see what my unit is and the configuration by clicking on the green icon on the right-hand side. By selecting that, I double-click. It drills into the detail for this analysis to where I can begin doing data capture. First thing is how I want my device to start doing the data capture of my communication link. In this instance, my buffer size on this particular unit is 18 gigabytes. So now after I configure my device, I also set my filter conditions. Filter condition is what information do I want to capture off of each link across the communications. Idle conditions, SAS and SATA idles, out of bounds, of signaling going on, specific patterns, the primitives. I have complete control for each link, and I can also control it by initiator versus target. What information is going to be captured into my buffer, or even multiplexed together. Moving on to the next area, trigger condition. Triggers allow me to control what I am looking for. That ties back to my buffer capture routine of what condition am I looking for, do I count and save into the buffer that I am looking for, the anomalous condition. There's automatic configurations of recognizing SSP commands versus data or responses. The whole trigger condition uses a state-driven programming aspect that allows you to look for responses within certain periods of time or certain sequences of events. So there's a very detailed control. We'll talk about more on this in a little bit. The next step, the status field, is looking at my communication. In this analysis, what I have is here's my buffer of what data is being captured in the buffer, and I can see, have I filled my entire buffer or not? I can also see the status LEDs that are on the front of the unit. I can see the status on my link here. My particular communication link, in this situation, I can see my speed is yellow, which is a 3 gigabit per second link. The link is up, and every once in a while I'm seeing a 10B error on this link. The bottom part is showing me some statistics. So now what I'm going to do is start some traffic so you can see how this operates. So now I'm going to demonstrate a data capture. First I'm going to generate some traffic in this communication link. I have a little batch file here that is just copying a data file from this remote disk drive onto the PC and then copying it back again between 2 different disk drives. That generates some traffic for me to be monitoring. Now when I start the capture, I see the capture buffer being filled, my 18 gigabyte capture buffer. I can see it's about 50% filled now, and it's just a first in, first out. When it wraps around, it's continuously capturing the latest traffic. I'm also seeing the status LEDs. In addition to the link LEDs, now I have frame traffic going across the link. I can also see that an LED that's indicating commands are moving across this link. On the bottom part of the screen, I can see statistics of the megabits per second, the number of reads, the number of writes, and the total for all the links. How much traffic is flowing across each one and the total network operation. There's even an option down here in the bottom to continuously log, so I can get long periods of statistical performance analysis on this particular measurement. There is a manual trigger condition I want to demonstrate. If I press the trigger on the front of the unit, I can see it mark the trigger condition. It fills in the rest of that buffer and immediately takes me into the capture buffer. To immediately jump to a different point of my capture buffer, all I have to do is double click at that point. So if I want to go to the beginning of the buffer, double click there, it synchronizes all my screens to that point of my buffer. If I want to look at an error message, I can double click on that error and it will take me to that location in my capture buffer. So this is a quick navigational tool for accessing any point of operation. In my decode, I'm looking at a transaction view. If I look at the host register, I select a specific frame and the full decode of information is available on the right-hand side. I want to point out that there's multiple decode levels in this unit. First off, I'm looking at a transaction view which shows me all the different messages that occurred where they're collapsing multiple commands into one operation. So there was 64 kilobytes of data transferred in one read command. So in my transaction view, what I can see is I'm in the middle of multiple read commands at this point. If I access over here where it looks like the data was much more compact, I double click on that point and it takes me to the new point where I can see that is a series of write commands that was being sent back across the link. So I can see my read and write performance are vastly different very, very quickly. As I navigate through, if I expand the write command, I can see all the individual SCSI commands that went across this link and they are fully decoded over here. If I transition to a different view, this is transaction view, spreadsheet view shows me all of the detail of that communication. So while there was the register here, there was all kinds of SATA R-ready commands and the synchronization commands and all the primitives that occurred. I go into the spreadsheet view to see those, or I can go into the protocol view and see even more detail, including the binary information of what was sent across the link. Full detail is available. Going back to the transaction view, I can see all the information here. If I needed to measure time, everything is time-stamped to 2 nanosecond time resolution. If I want to measure the time between 2 points, I can click and say, give me the actual timestamps versus the delta timestamps. I can mark 2 points and mark X and O markers, and it automatically calculates the time difference between any 2 points for my communication. And I can see exactly what's occurring. Thank you for attending this presentation today of the SAS and SATA protocol analyzers from Agilent Technologies. I hope you're able to see the value of having a deep capture buffer of up to 72 gigabytes for analysis of your SAS and SATA designs, the simplicity of capturing that data and doing a deep dive into the information to achieve the performance of your design that you need. Please come to the Agilent website or contact your local Agilent representative for further information or to get a unit on site for evaluation.